All right, FRQ1. Oh, I just remembered. I wanted to talk to you about scratch paper on your exam. Because in one of the forums I'm in, there were some people from, I don't know, probably a totally different state, and not anybody I actually know, but that there were issues on one of their, I don't know if it was AP Bio, it doesn't even matter, but something about somebody, whoever was proctoring it didn't handle the scratch paper correctly, so they were getting things clarified. So everything got clarified with books from College Board, which made me panic a little bit. Now, we don't ever have problem. Well, knock on wood. I mean, we have proctors. We get specific proctors. They know what they're doing. Our testing coordinators know what they're doing and make sure the proctors do. But this is a new hybrid exam, so I was still a little anxious about it. So I went to Miss Lair and I was like, look, I know you always take care of business, but I also have to take care of my kids. So I just need to have this conversation with you. And so here's the rules. So I want you to know what the rules are, because like I said, your proctor should too. But you start the exam with 5 pieces of scratch paper. Okay, and you can have more, but let's say you fill up your 5, then you can ask for another one, and you fill that one up. So after that, you get them one at a time to infinity. Okay, so don't be afraid to ask for them. The proctors do know that. She was like, yes, we know. So I'm just making sure. So like you already have 5 pieces of paper stapled together in your own little individual folder, so it will all be taken care of. But I don't want you to think that you are only limited to those 5. Now, some of you, like that are sitting in that middle table right there, could probably use a half sheet of paper and put all your work for all year on there, because you write so dang small. And you know who I'm talking about. It's beautiful, neat handwriting, but sometimes I think her paper is blank when I take it up. I'm like, oh, no, it's there. But anyway, but if you write big or you have to scratch things out, that's fine. Don't be afraid to ask for more paper. But then here's the other weird thing, is that it doesn't say in the instructions, it says to take it up at the end. It doesn't say to take it up before you start the FRQs. So technically you could use it, but don't, all right? I want you to think about the fact that the scratch paper is only for multiple choice. Anything you do for that FRQ needs to be in that FRQ booklet. All right. So I don't really like the fact that you'll still have that, because I don't want it to be like, oh, well, let me just draw it out over here and make my FRQ booklet pretty. No math teacher wants to see a beautiful, just answer type thing. Nobody ever asked for that. We want to see your work. We want to see your scratch work. We want to see your thoughts, so put it all in that booklet. All right. And just pretend like the scratch paper isn't there. Put it under your desk or something. All right. Okay. So let's look at FRQ1. The figure shows the graph of function f and its domain. Okay, so just telling you what I have. These 3 points are on the graph of f. So I'm going to go ahead and label them. Now, you will not have this graph on your piece of paper. So I don't know how easy or difficult it would be to actually put the points on the computer screen. Oh, it's up to you. But in your actual booklet, as you can see, you have a lot more room here than what I gave you on this little piece of paper. You could draw this, and it doesn't have to be perfect. Don't make the time to put all your little hash marks or whatever, but then you could just like label the 3 points there if you wanted to. But I'm going to go ahead and label them here so you don't have to look at my craziness. This is -3, 1, 0, 1, and 3, 1. Okay. All right, then function g is given by this. So pay attention to the fact that you have 2 functions. I have function f, which is the graph. I have function g, which is this equation. All right, I have 2 separate functions. I got to make sure I'm looking at the right one at the right time. We good? All right. So I've got that says the function h, which is not either one of those, is defined by this. Find the value of h of 3 as a decimal approximation or indicate that it is not defined. So if I want h of 3, that means I want g of f of 3. Okay? Everybody agree with that? Where do I go to look for my f values? The graph that they gave me, right? So I go back up here, f of 3. Oh, look, they literally flat out gave it to me. So f of 3 is 1. So I really just want g of 1. Here's what I'm not going to do. And you may have done it, and it doesn't make it wrong, but I'm going to show you why it's really not the best idea. I'm not going to take 1 and substitute it in here and use Desmos as an actual calculator, right? Just to multiply numbers. Again, it's not wrong, and it's not bad, but this could be some crazy out there thing. The whole purpose of using and having these calculator sections is to let the calculator do everything for us and use it not just for computations. So we're going to go to Desmos, and I actually did have this typed in, but it keeps resetting itself. And we're going to type in that equation exactly like it looks. G of x, so everybody type it in, equals 2.916 times 0.7 to the x power. Okay. Now this is exponential. It could be a lot of things. It could be maybe something that you're not 100% familiar with, but I mean, you pretty much know what an exponential looks like, I would think. All right, so if I look at what I actually wrote down, I need g of 1. Now that I have this typed in, I'm going to type in g of 1. Bam, there's my answer. Okay, so especially if it's like a quadratic or a cubic where you'd have to put in a number and cube it and put in a number and square it and do all that stuff, you don't want to have to type all that in. You let the calculator do everything. And so here we get that this is equal to 2 point something. Where's my answer key? 2.0412. Now, you have to be correct to how many decimal places? Well, yes, my rules. You have to, according to College Board, you have to be correct to 3. I do tell you to do 5, right? Kind of, well, actually, I started the year with 4, and then I changed it to 5 because it does most, and I'm sorry, but we're still growing. They only gave me 4, and that is fine. Even if they only gave me 2, that is fine, because that would mean that's all it does, all right? But do not just stop at 3 if there is more than this, mainly because there are still some people, enough where I have to say this, that are rounding. And I have told you to stop rounding. The problem is those of you that are rounding are doing it wrong. So you're the ones that really need to stop. So if you write down 5 and then you round wrong, your first 3 should still be right. I'm trying to help you out here, okay? Plus, there's other reasons why we might want to do that. So it's totally fine to have more. We have to be right to the first 3, okay? We all good on that? Okay, beautiful. So now this next part says, find the values of x for which f of x equals 1. All right, so look at what you wrote down as an answer. If you did anything other than x equals and write down some numbers, you did too much, okay? Because some people tried to write them as ordered pairs or write as other things, and it's not wrong if you're 100% correct. But don't do more than you need to, because that's when mistakes happen. If I want to look for values of f, am I looking for the graph they gave me or the graph I made? The one they gave me, because that is f. So I go up here, and lo and behold, they actually gave me that too. And you see how much easier it is to look at because I plotted them on there? There are 3 answers right there. -3, 0, and 3. -3, 0, and 3. And I think that these 2 points are fairly simple. And if you did not get them, I'm not saying that to make you feel stupid. I'm saying that for you to realize now that you probably did something weird. Again, you know, we overthink things, and we hadn't really reviewed this stuff or done a whole lot on FRQ1. So it's fine that we're not perfect. But I want you to see that it's really not that bad, and you can totally get these points, right? We good? Any questions? All right, so now we are on to find all the values of x as a decimal approximations for which g of x equals 2, or indicate that there are no such values. So again, I just have a plain old x equals. The question implies, because decimal approximations implies there could be more than one answer, or there could be no answers, or there could be one, right? There's a lot of things that could happen. For this one, am I looking at the graph they gave me or the graph I made? The graph I made. And you see this right here? That's exactly what you type in. So we go over here and we type in g of x equals 2. Bam. Oops, I don't know why I put a plus. Sorry. I was trying to do that. Now, this is exponential. You should have some idea of what it looks like. You know it's not going to come down here and then come back up, right? If it is a rational or something else maybe you don't recognize, maybe we need to zoom out a little bit. If it's a quadratic, absolutely zoom out, because it's probably going to intersect at more than one point depending on where we went, or even a cubic. But this one, because it's that, it's not going to come back up. So when g of x is 2, my input is that number right there. 1.05 something 717. Everybody good so far? All right, we haven't done anything crazy yet. Then it says to determine the end behavior of G as X increases without bound. Express your answer using the mathematical notation of a limit. Now, it's been a minute since I graded these, but if I remember correctly, I know not everybody got this point, but I didn't have to not give you the point because you couldn't write a limit correctly. Like the format, if I remember correctly, was correct from everybody, which is great. But then the answer was not right. But that format was something we were still struggling with last year at this point. I don't really know why. But before I even worry about what my answer is, end behavior, I got two ends. Am I writing two limits here? No, because it says as X increases without bound. That's only one. So I'm going to write the limits as X approaches what? Infinity. Okay, remember, those are stacked. So even though we didn't have any issues, I just want to remind you that how to write this. And then I have to have an argument of G of X. And that's going to equal something. The something is what got some of us. All right, so this is G. Am I looking at the graph they gave me or the graph I made? Made. So ask yourself that every time so you don't use the wrong graph or wrong whatever. So I'm going to come over here. All right, so as X increases without bound, what is Y approaching? 0. And it's an exponential, so we know there's an asymptote, and this is 0. Okay, little side note, because I don't remember if I said this in here yesterday or not. If I did, you can stop me. But I had a question earlier in the day yesterday that somebody was watching the first AP Classroom video that I gave you notes for, and they were talking about limits. And he said one of them, they did this, something like this. I don't know exactly what it was, but equals 0 or whatever. And he said, that's not right, is it? And I said, no, it's not right, because you're missing the argument here, right? And he said, well, they did that. And I was like, did they do it on all of them? He was like, no, they just like on 2. Like they were doing it all correct, and then they didn't. And so I'm saying that because it's an AP Classroom video. I don't want you to think because you saw it on here like this that that's okay. But it does make me feel better because I'm just putting my videos out there for y'all. They're putting them out there on the College Board website, and they're doing the same ridiculous things that I would, that we're all capable of, is what I say. So that, I just want you to know that that is not okay. You have to have the argument there. Okay, we good on that? All right, any questions at all? All right, beautiful. So another, I think, semi-easy point, right? All right, so then we're going to determine if f has an inverse function. F is the graph they gave me. So let's talk about how we determine if it has an inverse. Well, to determine if something is a function, we have the vertical line test, right? That's old news. If its inverse is a function, then after I reflect it in the line y equals x, it basically gets turned 180 degrees. And then it would look like this, and I could do the vertical line test, right? So we basically can use what's called the horizontal line test to see if when I take the inverse, I'd have a function. You with me? Also, somebody asked me today about the word invertible. When they start talking about this, they use the word invertible in those in the video. I think when we first got these last year, when it asked if there was an inverse, instead it said, is it invertible? And I think that blew a lot of people away. So you don't have to use the word. It just means, is there an inverse, is what it's asking. That's what invertible means, but we don't have to use those words. But do you see how it fails the horizontal line test? That means that the inverse is not a function. So on this part right here, your answer, it's a yes or no question. It is no. Okay, that's it, just no, right? And I think they've split a lot of these up because they're like, can you come up with an answer? And then can you explain why? On C1, if they ask you that, you got a 50-50 shot. If you have no idea, pick one. Don't leave it blank, okay? I mean, just yes or no, take a stab at it, right? So then we have to give an answer based on the definition of a function, and you have to use points from the graph or the table, if there is one, to justify yourself. It doesn't say that here, but they didn't give anybody the point if they didn't do that. How we were supposed to know to do that? Not real sure, but whatever. But I think it actually says that now. But even though we just did the horizontal line test, you cannot use the words vertical line test and horizontal line test. Well, you can use them, but they don't, you have to say everything else anyway, so we're just not going to use them. The easiest way to do this, to make it, it doesn't even say to talk about an inverse. It says to talk about a function, right? Why it does, this doesn't have an inverse because, and we talk about the function. So I'm not even going to use the word inverse in my explanation. So instead, when I look up here, and I want to try and get this right, this fails the horizontal line test because basically I can use these 3 points in a row, right? You see this output value? It shows up 3 times. So the output value of 1 does not come from unique input values. So there are other ways to word what I'm going to tell you, but this is kind of the most concise and probably easiest way without writing a paragraph. So we can say there are output values that are not mapped from unique input values. Okay, I have output values that are not mapped from unique input values. Makes it the original be a function that just fine, but that means the inverse is not a function. And then we have to give an example, and they gave me 3 points. I can say f of -3 equals f of 0, which equals f of 3, and all of those equal 1. And I don't have to have 3. I don't even have to use all 3. I would only have to have 2, but they gave me 3, so I might as well use them. But just any two of those that I wrote would just, make it not work to begin with. So this is worth a point here, and this is worth a point here. Now, if you go through all of that and you're like, okay, got it. I hate those wordy things. I get all mixed up on that stuff. Well, it's not the end of the world. You could still confidently, hopefully, get 5 out of 6 points, right? It is highly unlikely that a great majority of you would get all 6 points on all of them. It's actually unlikely that any of you would, okay? Not because you're stupid, but because that's how they write the test, okay? So it's okay. Like it's fine. It's really fine. We just get as much as we can, okay? What questions do you have? Anything? So if you did not get 6 points on that, do you think you could at least get more than what you got? Yes? Okay, and that's what we're going for here. Any point we can grab anywhere. Be a point hog for sure. All right, so grab those blue papers. You can put your computers away. Put your FRQ booklets back in your folder. Once we do FRQ2, then you can take those booklets with you. But I don't want them to not be here when we need them. So we are going to start here, and this is going to go on page K when we're done. K for Karen because she got an award last night. That's right. That is Karen Zuniga. What's your ID number? All right, we ready? So start with 1 of 2, with the one with the table at the top. Not as many pieces of paper as yesterday that we were shuffling through. Okay. So this is just like a concentration on part C, because the parts A and B, that's typing it in the calculator, knowing what to do. But part C could be asked different ways. So we just looked at one way part C could be asked. Here's a totally different part C. Either one of them are fair game. This one doesn't ask about an inverse. It asks about what kind of function type, all right? So based on the table, which of the following function types best models the function? Linear, quadratic, exponential, or logarithmic? And notice, like we had a lot of these questions where it would say linear, quadratic, or neither. Neither is not an option. So if you think neither, then something's wrong, okay? The first thing I would always look at is my inputs. So I'm going to see if I have equal length input value intervals. So that's 3, that's 6, that's 12. I'm going to go with no, okay? I do not have equal length input value intervals. Only one of those 4 doesn't have equal length input value intervals. Which one is that? Which one where the input values are not like 1, 2, 3, 4, 5, like they're not evenly split? It's the log, okay? Log is when it got weird, right? you've got linear and quadratic. Obviously, we're going to have those equally spaced. Exponential as well. But then when we take that inverse and we put the exponents, or we put the variable inside the log, then it's easier to do it the opposite way. Okay, so exponential, I could still have inputs of 1, 2, 3, 4, 5, and it's my outputs that are multiplied, right? That's why it exponentially goes faster. Log, it's the opposite of that. So when my input value intervals are not equally spaced, my answer is logarithmic. This C1, that is the only thing you put, is one of those 4 words, and this one is logarithmic. Now, there is no deduction for spelling. However, if you spell it so bad they don't know what you're talking about, that's your own problem. Plus, the word is right there. Just copy the letters. Okay. So then I'm going to look at my output values. Well, my output values are actually equally spaced, right? And you need to make sure, because most of you do this correctly, but there are some of you that don't. When you do this, you have to make sure you are subtracting or dividing in the correct order. I did 20 minus 10 and 30 minus 20 because the signs I get here matter, or what I get on the other parts matter. If this is logarithmic, I don't care about this being addition and subtraction. For exponential and logarithmic, things are changing proportionally or multiplicatively, right? We're multiplying. So I got to figure out what my multiplier is. Again, you have to do it in the correct order or you get the wrong number. If I take 6 divided by 3, that gives me 2. 12 divided by 6, that gives me 2. 24 divided by 12. If I went the other way, I'd get 1/2, and my number would be wrong. You with me? So it's always second minus first, or second over first. So for logarithmic, your output values are equally spaced, and then your input values are changing multiplicatively. We good on that? All right. So then we're going to write our answer here. And you can write this either way. You can talk about inputs, then outputs. I think that it's probably better with talking about the equal length intervals first, just because we can be consistent. In this case, they're outputs. So we would say output values are equal. Wait, my brain is, that's fine. All right, we can say equal, my words are not coming out right. It's not wrong. What I wrote is not wrong. It's just not the words I'm trying to get out. We have equal length output value intervals. I guess that's all I have to say. Oh, over equal length. I'm sorry. My God, it's been a long day. I'm trying to not see. Here's what happens. If I'm not consistent, I can write out the right answer, but it'll be like a paragraph because my brain is just. So I'm trying to get like the simplest way for you to understand, so you don't have my nonsense words in there. But if that's what you end up with, like more words because you have it like mixed up, it's totally fine. You with me on that? But let me put it the way that probably would make sense. I just couldn't get my first word out. I've been writing it all day. I haven't had that issue. Okay, so I'm going to say over equal length output value intervals. Okay, and if it was the inputs, then I'd write the same thing but put input. But over equal length output value intervals. Okay, then we talk about our input values. Input values are changing. You could use proportionally or multiplicatively. Proportionally. I let second period decide what we were going to use today. They were like, proportionally? Multiplicatively. It's hard enough to say, even worse to spell, right? Okay, are changing proportionally by a factor of 2. That's why it's so important to get those numbers correct. Now, I've kind of gone back and forth with y'all on that because we started off, because we've written these a bunch, it's been a while, but we were doing, it says fact, that should say factor of 2. And we were putting the factors in there, and then I was like, you know what? Some of y'all are doing this stuff backwards. Let's just say they change proportionally. But then, and this is why I really cannot wait for pre-cal to get a few years under its belt. That way we have a much better understanding of what they really want from us. But because if some people ask these questions, blah, 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 and it literally says the table of values, I feel like we should use that. But if you can't multiply and divide correctly at this point, I can't help you. So just make sure you get the right number. I mean, I was trying to protect you, but I'm like, I can't protect you from arithmetic all the time. Okay. We good? Any questions? All right, let's jump to number 4. Right here. All right, number 4. It's on just on the back of that page you're on. So I'm going to start by looking at this. All right, I got equal length input value intervals. So what can I knock out as one of my answers here? Logarithmic. And at this point, this may or may not help you, but I can write the first half of my explanation, even though I don't even know what my answer is yet, because I can say on here, over equal length, and this time it is input value intervals, okay, and then I'm going to stop because I don't know what else to say, but I got the first half of it in there, right, before I even got lost in anything else, which hopefully we don't get lost, but all right, so then I'm going to look over here. I got rid of logarithmic. If it's exponential, then I'd have a factor I'm multiplying by. Well, -5 over -10 is not the same as 4 over -5. So I'm not going to have, so it's not going to be exponential either, right? So it's either linear or quadratic, I hope, or we have to go back and figure something else out. And again, you have to be able to add and subtract positive and negative integers correctly. -5 minus a -10 is 5. 4 minus a -5 is 9. Then this is 13, and this is 17. So what else can we knock out? Linear, okay? And we hope to God it's quadratic, or we got to start all over, right? So then I do these, and this is 4, 4, and 4. So my answer now is quadratic. Now, if you start your explanation, don't forget to go finish it. Don't see words there and be like, oh, I'm done, because you're not. There's a couple of ways we can explain this. And if it was multiple choice, there's basically 3 different things they could say here. All right? This right here, when you do your differences, these first differences, that is your rate of change. Okay? You never, ever abbreviate rate of change in an explanation with ROC. You can do it for yourself, but not when we're writing out answers. Okay? Because it's still up in the air. It's not worth the risk. This can be talked about as the change in the rate of change. Okay? That makes, oh my gosh, change in the rate of change. So rate of change, change in the rate of change. Or first differences, second differences. Or we could say the rate of change is linear. And that's the one that really blows your mind. But that's because the slope of the rate of change is constant. So we don't have to get fancy when we answer it, right? If it's multiple choice, we got to make sure we make sense of all of them. The easiest one to talk about, and I'm pretty confident that it's okay answer because I can't get anybody to tell me for sure, but it's the only one that makes sense to write. Then we would say over equal length input value intervals. Second differences of output values are a constant of 4. Okay. Everybody good so far? And remember, that chart is not going to be on your piece of paper, so you're going to need to write those numbers down so you can actually do that stuff, bless you. Unless you can write on the screen somehow, don't just stare at it. That's bad. Bad. It's bad for me too. It's bad for everybody. All right, questions? All right, grab your other piece of paper because we got enough time as long as they don't come on with 1,000 announcements. I just want to get part of this done so we can talk about it real quick. Let's look at number 1 here. Another graph one. This is also going on K. This says to determine if F has an inverse. Okay, so we can determine with the horizontal line test, but we can't use it as a reason. Do you think that F passes the horizontal line test? Yes, it totally does, because this doesn't go flat because there's an asymptote, right? So it's yes, which means the answer is yes, right? That's an easy 1 point, right? Easy 1 point. Don't miss that point. Then we have to give a reason. All right, so on our mock, the answer was no. And I told you, you have to use points because that's what they made a big deal about that last year afterwards. So points, using the points when the answer is yes didn't make sense to me because like, how do you prove that with, it doesn't make the same, not the same thing. But so instead of saying, we said no because there are output values that are not mapped from unique input values. For yes, we're going to say all output values are mapped from unique input values. And so we're still talking about them, but like giving specific numbers doesn't make any sense. If you're worried about getting the input and the output mixed up, I think it's always good to take something that might be complicated to you or confusing to you and connect it to something simple that you understand, like a quadratic. Okay, a quadratic is a function, right? Does it pass the horizontal line test? No. So this answer would be no, right? But if I just pick two random points, and you can make them whatever you want. Let's say -3, 1, and 4, 1, because we just would know they'd have the same y value, right? So then you can look at this and go, all right, if I'm going to say no, it's because the output value of 1 does not have a unique input value. So when it's yes, all of the output values have unique input values. Then you can get your words in the right place. Okay, nothing wrong with little sketches. Don't use your scratch paper for that. You can write it over on the side of what you're doing. It's totally fine. Okay, I'm really worried about this scratch paper situation. I don't want y'all writing stuff on there when you should be writing it in your booklet. But I think you're smart enough. As long as you're told, you can think about what to do. What questions we got? Where are all the cool kids going to be on Saturday? In the MMC. That's right. And Monday after school as well, right? And we're going to stuff ourselves with donuts and pizza, and we're going to do some pre-cal, right?